Hey guys, we're going to get right into it today. It's Chapter 8, Section 2. I can graph quadratics. That's our learning target. Go ahead and get that written down. Okay. I have to move this paper because someone called me while I was in the middle of making the video, and I don't have an extra copy of the notes, so it's going to be a little, fun for the first side. So recall that standard form of a quadratic equation, that is ax squared plus bx plus c, where a and b are the coefficients. I'll let you get that written down. Now, it says quadratics calculator lab. We obviously didn't do that given, our current situation. So we're just going to go right into reviewing. Now, what does the a value tell you? In regards to the direction of the parabola, which way it opens up, if A is positive, it'll open up. And if it's negative, it's going to open down. Okay, so the number in front of the x squared will dictate if it's opening up or down. And then the shape in comparison with y is equal to x squared. If a is greater than 1, it's going to be more narrow. If a is 1 or negative 1, it'll be normal. And then if a is less than 1, it's going to be wider. Okay, so as a gets closer to 0, the parabola will also get wider. Okay, let you get that written down. Now, what does the c value tell us? That is our y-intercept, so that's at 0, c. Just like in a y equals mx plus b form, where the b, the number all by itself, is the y-intercept, it's the same thing here. Okay. And what does the b value tell you? If b is positive, it'll move the vertex to the left. And if b is negative, it will move the vertex to the right. So whatever number is with your middle term there, that will move the vertex left or right, depending on whether or not it's positive or negative. Okay. And these are all of our steps to how we want to graph a quadratic function that's in standard form. After we identify a, b, and c, we need to find the y-intercept, which will always be your c value. And then we're going to find the axis of symmetry using the formula x is equal to negative b over 2a. So that would be when we plug in our values to find that. I spelled values. There we go. And then if we want to find the vertex, we can plug in our x value from the axis of symmetry into the equation. That'll make more sense when we actually do one, okay? So if that worries you right now, don't let it worry you. Then we're gonna find another point, and then we plot everything, we reflect everything, and then we connect the points. So I'll give you a second, and then you can go ahead and flip it over. Okay. All right, looking at the top one, this is when someone rudely called me. So I'm just gonna cover it up again. I need to identify a, b, and c. Your a value is what's with x squared. Your b value is with x, and your c value is the number all by itself. Okay, so a is going to be 1, b is 4, and c is 2. Now, your y-intercept, that is a number all by itself, or the c value, so it is at 0, 2. Okay, and then your axis of symmetry, that's when you're going to use the formula x is equal to negative b over 2a. Okay, so my negative b would be negative 4 all over 2 times a, or 2 times 1. Negative 4 over 2 is negative 2, so my axis of symmetry is that x is equal to negative 2. Okay, now I can stop covering it up. So now that I have my x value, remember the axis of symmetry always goes through the vertex. So we know part of the vertex, we just don't know the y value, okay? So I'm gonna plug in my -2 into my top equation, okay? So I have -2 squared plus 4 times -2, okay? 4 times -2 plus 2. Okay, now I'm going to simplify it. -2 squared is +4. 4 times -2 is -8. And then I have my +2. Order of operations, I'm going to work left to right. Okay, 4 minus 8 is -4. -4 plus 2 is -2. So that means my vertex is at -2, -2. This would be my y value for the vertex. Okay, so this would be y equals, just like it was up here. Okay, I'm not gonna let us know if it's a minimum or maximum yet. Maybe you can figure it out though based on what A is, but we'll get there after we graph it. And I'm gonna leave the domain and range alone as well right now. So I'm gonna graph my y-intercept, which is at 0, 2. And I'm gonna graph my vertex, which is at -2, -2. Now my vertex also had my axis of symmetry, so I'm gonna make my dotted line going down. Okay, now I'm gonna reflect, no, I'm not gonna do that yet. I want you to get out a separate sheet of paper, unless you can do it right here. You might be able to, you probably can. I'm gonna do it on a separate sheet of paper though, so you guys can see, because we need that extra point. So I'm gonna do a little table X, Y, and I am going to make X equal to 2. And that means I'm just going to plug 2 into my original equation. So I have x squared, or 2 squared, plus 4 times 2 plus 2. Now I got to simplify it. 2 squared is 4. 4 times 2 is 8 plus 2. 4 plus 8 is 12. 12 plus 2 is 14. That probably isn't the best one to do. That's going to go off the graph. Why don't we do 1? That's why we said pick wisely. You see why you have to? So it's going to go off the graph now. I'll do 1. So I have 1 squared plus 4 times 1 plus 2. 1 squared is 1. 4 times 1 is 4. And then I add my 2. 1 plus 4 is 5. 5 plus 2 is 7. So that means I have a point at 1, 7. So I'm going to plot that point now. So at 1, 7. Okay, and now I'm going to reflect everything. So what that means is I'm going to start on this point, and I'm going to count how many until the axis of symmetry. So I have 1, 2, and then I'm going to count that same number in the other direction. 1, 2, 1, 2. And that's where it plots. So they would land on top of each other. And now I have 1, 2, 3, 1, 2, 3. Okay, and now I'm going to connect everything. So looking at my graph now, is this a minimum or a maximum? If it is a minimum, that's the lowest that those points will be. The domain is going to be -infinity to +infinity, because that's what it always is. Now, look for my range, I need to look at my y values. My y goes as low as -2, okay? But then it can be anything bigger, because that's where the parabola is going. So my range is going to be y is greater than or equal to -2. But if I want to write this as an ordered pair, I'm going to have it be -2 to positive infinity, because it can be -2, but the y values are going to keep increasing as the parabola increases. We can see that it opens up, and this is a normal graph because a is 1. And you can tell that it's normal. You'll really be able to tell if it's narrow or wide in most cases if you weren't looking at a, but that'll always help you as well. All right, the next one, identify A, B, and C. A is -1, B is -4, and C is 2. My y-intercept is the same as my C value, so that is at 0, 2. Now my axis of symmetry, my formula is x is equal to -b over 2a. So very important that that sign is identified here because it's -b or the opposite of b. So it's -4. And then it's all over 2 times a. Now, negative times negative is a positive. So x is going to be equal to 4 over -2, because 2 times -1 is -2. And then 4 divided by -2 is -2. So your axis of symmetry is that x equals -2. Okay, now your vertex, you are plugging in the axis of symmetry value into the original equation. So I have y is equal to -2 squared minus 4 times -2 plus 2. Okay, get that written down. All right. -2 squared is 4, but there's a negative outside that needs to be taken into account. -4 times -2 is +8 plus 2. -4 plus 8 is +4. 4 plus 2 is 6. So our vertex is going to be at -2, 6. Okay, now I'm going to find my third point. Okay, I already have x at 0. I already know 0 and 2 is an ordered pair. Now, you know what, before I find my third point, I want to show you what it really means to pick wisely. So I'm going to graph my y-intercept, which is at 0, 2. Okay, and then my vertex as well, which is at -2, +6. And I know my axis of symmetry goes through the vertex at x equals -2. And I'm actually going to reflect this over now. Okay, so it's 1, 2, and then 1, 2. Now, I need a third point, but the reason that I said we should pick wisely, it wouldn't make sense for us to do like 8 or something, right? So just a point that's closer. I'm actually just going to do 1. Okay, so I plug in my 1 for everything. So I have -1 squared minus 4 times 1 plus 2. 1 squared is 1, but that negative sign has to stay, unfortunately. -4 times 1 is -4, and then I add my 2. -1 minus 4 is -5. And negative 5 plus 2 is negative 3. So that means my third point is at 1, negative 3. Okay, that one there. You can always pause the video too if you need to copy it down longer. I just don't want to make you guys wait for an obnoxious amount of time. So that third point was at 1, negative 3. And then reflect. 1, 2, 3, 1, 2, 3. And now I can connect. So this is a max value. We see that it opens down. When A is negative 1, it's still normal. And you can tell that's about the same size as that, minus my little kind of messed up on that little drawing part, but you can tell that it's the same. That's what a normal one would look like. My domain is going to be negative infinity, positive infinity. In my range, I got to look at my y value and everything that y is. The highest that y is 6, but y is going to decrease. So y can be anything less than or equal to 6. Now I need it as an ordered pair. 6 is the highest that it can be, so I know that 6 is going to go on the right-hand side. And it's going to be negative infinity to 6, because y can be anything smaller than 6. It can be anything negative, 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 all the way up to 6, right? But 6 is the highest it can go. So that's my range. And that's it for that problem. Okay, our very last one, y is equal to negative 2x squared plus 8. If you notice anything different about this problem, it is that there are only 2 terms here, not 3. My a is negative 2. My b is 0. And my c is 8. Okay, there is no b value. My y-intercept is the c value, so I have a y-intercept at 0, 8. My axis of symmetry is that x is equal to negative b over 2a. Negative b is going to be negative 0 all over 2 times negative 2. But 0 divided by anything is just going to be 0. So my axis of symmetry is that x equals 0. Okay, vertex, I plug in my axis of symmetry point into the original equation. So I have y is equal to negative 2 times 0 squared plus 8. 0 squared is 0. 0 times anything is 0. So this is just going to be y equals 8. So my vertex is 0, 8. Okay, and now I'm going to graph everything. So my y-intercept is 0, 8. And I don't have another point to graph yet. So I'm actually going to take out my table again, and I'm going to find 2 points. X, y. I have 0, 8. I'm just going to do 1. It's nice and close to 0. So I would have negative 2 times 1 squared plus 8, because that 1 got put into the equation. I'm sorry, 1 squared is 1, and then negative 2 times 1 is negative 2. And negative 2 plus 8 is 6, so that means I have a point at 1, 6. And I am going to graph that. And I do need one more point, and I'm just going to do 2. So when x is 2, what is y? I have negative 2 times 2 squared plus 8. 2 squared is 4. Negative 2 times 4, negative 8. Negative 8 plus 8 is 0. So I have a point at 2, 0. 1, 2, 0. And I know my axis of symmetry is the vertex. We already identified it. So it's actually right through the y. And now I'm going to reflect. So 1, and then 1, 1, 2, 1, 2. Really ugly line. I apologize. We know that this opens down, and if you were to compare it to a normal graph, you do see that it is more narrow, and that is because A is further away from 0. Okay, now my domain, negative infinity, positive infinity. This is a maximum value because it's the highest point. And the range, I got to look at my y value. Y goes as high as 8, but it's going to only get smaller. So y is going to be less than or equal to 8. And just like this problem up here, because it is decreasing and y is going to be less than or equal to 8, it's going to be negative infinity to 8. Okay, remember that we close our brackets because it can be those numbers, but it stops. Negative infinity and positive infinity, you can always add or subtract 1, so it'll be different. All right, I hope that made sense to you guys. If you have any questions, please feel free to reach out to me. I'll kind of zoom in on these for a second, just so you can make sure that you got everything written down correctly. And then feel free to pause whenever. Okay, bye guys.